Welcome to Strange Bites, the podcast where we unearth the world's most unsettling discoveries and weave them into creepy tales darker than the deepest ocean at midnight. So grab your life jacket and jump on the boat. We're sailing into episode 11. To be alive or not alive? That is the question. It's a quiet night off the coast of Shimoda, Japan. A small research boat bobs on the waves. The ocean is ink black, the kind of unrelenting dark that swallows life whole. On board, scientists lower a fine mesh net into the depths, fishing not for fish, but for the invisible. They're hunting the tiniest secrets of life itself. They haul up a jar of glowing plankton and other microscopic life, but one particular creature stands out. Catharotesis regius, a single-celled dinoflagellate that looks like a microscopic spaceship with a built-in pouch, like a kangaroo pocket. Inside the pouch, symbiotic bacteria that help it survive, or so everyone thought. But later, in two dimly lit labs halfway across the world from each other, Dalhousie University in Canada and the University of Tsukuba in Japan, two researchers, Ryo Harada and Takuro Nakayama, decided to look closer. They plucked out one single plankton cell. They washed it over and over, like scrubbing away every trace of the outside world. Then they cracked it open with the gentlest tools science has, a special kit called Repligy that makes millions of copies of any hidden DNA. They feed it into two powerful gene-reading machines, one that spits out short, accurate snippets, Illumina, and the other that reads long, twisted strands, Oxford Nanopore. The computers hum in the dark. The data pours out, and there it is. A perfect, tiny, circular loop of DNA, only 238,000 letters long, smaller than anything ever seen in these ancient microbes called archaea. The scientists blink at the screen. "This can't be right," they whisper. "It's too small. It must be a glitch, or something that shouldn't exist." But it wasn't a glitch. They ran the test again and again. The circle was real, clean, complete. They named it Candidata Sucunarchaea mirabile, the marvelous little Sukuna Archaeon, after a tiny Japanese god called Sukunabikona, and mirabile because, well, it's miraculous. Here's where the story gets darker. This thing isn't like any microbe you learned about in school. Normal archaea have instruction books, genomes, full of recipes for eating, breathing, building walls, making energy. Not this one. Its 189 genes are almost all about one thing: copying itself, DNA replication, making messenger RNA, building its own tiny protein factories called ribosomes. That's it. No recipes for food, no way to make its own energy, no tools to build a protective shell. It's a ghost that only knows how to replicate. It lives inside the plankton's pouch, like a shadow hollow parasite, stealing everything it needs from its host and giving nothing back. A pure taker. It can't survive anywhere else. Scientists haven't seen it under a microscope yet. They can't grow it in a dish. All we have is its DNA whisper, floating in the data like a message from the edge of life. The ocean keeps its secrets well. But this one slipped through the net in 2025. And now, in 2026, papers in Science and reprints on bioRxiv are lighting up the scientific world. This tiny shadow isn't just small. It's evolving right on the blurry line between a living cell and a virus. It has the machinery of life, but only the copying part. The rest? Stolen. So what does this whispering shadow mean for us? It forces us to stare into the mirror of existence and ask the oldest, darkest question: what is life? For billions of years, we thought life needed metabolism, energy, independence. Sucunarchaea mirabile laughs at that. It's a cellular entity stripped to its replicative core, alive enough to copy its own instructions, parasitic enough to need a host for everything else. It blurs the sacred line we draw between organism and virus, between self and thief. Philosophically, it whispers that life isn't a checklist of abilities. It's a spectrum, a negotiation, Maybe the very first life on Earth looked something like this. Bare bones replicators hiding inside luckier cells, slowly trading genes until complexity bloomed. It reminds us that evolution doesn't care about our neat categories. It cares about what works in the shadows. And the future implications? Terrifyingly beautiful. In synthetic biology labs, scientists may one day build minimal cells inspired by this ghost. Tiny biological machines for medicine, carbon capture, or even space travel. Imagine sending these ultra-efficient replicators to Mars or Europa to test if alien oceans could host something just as stripped down and strange. It could rewrite how we hunt for extraterrestrial life. NASA's rovers might be looking for the wrong signs. Maybe the first alien life we find is a Suchanarchaeum-like shadow, invisible until its DNA whispers through our sequencers. Ethically, it challenges us. If something this minimal can exist, where do we draw the line on creating new life forms in the lab? On patenting minimal genomes? On deciding what deserves protection? This discovery from a single glowing plankton doesn't just shrink the record books, it expands the mystery. Life isn't loud. It's the quietest shadow in the deepest ocean, copying, stealing, surviving, whispering that the boundary between alive and not alive might be thinner, darker, and far more marvelous than we ever dared to imagine. Thanks so much for listening. I really appreciate it. And if you enjoyed this episode, please subscribe, give me a follow on Facebook and Instagram. And until then, stay strange and question everything.